JavaScript is great. You have total freedom until your own mistakes kick you in the head like Bruce Lee. So, I'm here to teach you an ultimate defense, the ninja skill called TypeScript. This video is the first in the series, where we deep dive into the TypeScript language. Today's vid is the first kata, where we warm up by learning the very basics. So, let's jump right into the code editor. Let's start by casually initializing the project and installing TypeScript as a dev dependency, type npm init-y and npm install-d TypeScript. But wait, Piotr, this is just project like any other. Just one package installed. Right, mine Padawan. We're missing the TypeScript configuration. TypeScript is compiled language, and we need to tell the compiler what rule sets we want to in our codebase. So let's run npx tsc-init. tsc is the TypeScript command line interface, and the init flag allows us to start a project. It generates a tsconfig.json file. As you can see, in this file, we set some compiler options like the targeted version of JavaScript, the version into which TypeScript code will be translated after build. I'll explain some of the other options later. For now, it's enough to know that we need tsconfig to run anything. Perfect! Package installed, config added. What is missing is the actual code. All TypeScript files must have ts extensions. Let's create a file called index.ts. TypeScript is a superset of JavaScript, meaning all features of JS are present in it, plus we have some additional features. For example, variable types. In JS, primitives may be string, number or boolean. But if I declare a variable hello and assign a string to it, there is no problem reassigning it as a number in JavaScript. TypeScript doesn't allow that. Here, we have a pretty error saying that number is not assignable to type string. Basically, in TS all variables have some type associated with them. When we initialize the hello variable, the TS compiler marked it as type string. This is called implicit typing. We can also mark types explicitly. All we do is put this funny colon after the variable name and specify the type. We can use the following types. Kinda self-explanatory. Don't be scared about void or unknown. I'll explain these bastards later. Now, let's do what all responsible programmers do. Let's console log. Perfect. Now we have code that does something. Maybe not something you will put on your resume, but still something we can test. But if we try to run TS code directly, we receive an error. TypeScript is a language we use during development. It's just our helmet. In production, we actually run compiled JavaScript. To compile, let's run the command npx tsc. As you can see, we now have an index.js file inside our project. Magic happened. When we run node index.js command, our super turbo advanced code works. But there is a small issue, I would say. Imagine your codebase is bigger than this little I'm learning TypeScript mom repo. Having multiple TypeScript/JavaScript files alongside each other is not super clean. Normally, we put such compiled JS inside dist or output directories. To do so, we may add the dist flag to our compile command and specify the output directory. Or, even better, we may set it inside our TypeScript config. Perfect. Maybe last small improvement. Normally, we set a build script in package.json. So let's do that. Now, when I run npm run build, everything lands in the dist directory. Awesome. Nice, Piotr, you bored us to death with this config. Could you show us something useful? Sure, on it. Let's go back to the index.ts file. Now, let's suppose we're working on some social media app and our task is to display a user's birthday. In JS, we simply take the user object and hope that it has all required properties. But not on TypeScript's watch. TypeScript allows us to define something called types. A type is just a set of defined values or behavior that an object has. For example, let's create a user type. We only need to use the type keyword, give it a name, and assign what we need. Basically, this just looks like a kind of variable, right? Let's say our user has a name. which is a string, a birth date of type date, and an email of type string. As a variable type, we may assign any primitive, object or function. This will all make more sense when we use more TypeScript. But again, Piotr, why the heck do I need that? First, let's assign this type to our function input. First, what we get is code completion. Nice feature, but is this bulletproof protection against bugs? Well, sort of. But not only that. Check this out. Just try to call this function, but mess up the types. Ours IDE shows TypeScript errors. Moreover, if you just ignore that, you're a red color fan, and try to compile, it will fail. TypeScript will throw a compilation error. So TypeScript makes sure you don't make stupid mistakes like mistaking a boolean for a string. But are those types only for inputs? No, absolutely not. We often assign a function's value to variables. For example, what if we assign displayBirthday to a variable? This makes little sense because this function returns nothing. But for such scenarios, we have a special keyword called void. As you can see, the variable has a void type because TypeScript implicitly marked the type for us, but we may do it ourselves. After the input parentheses, we can set the return type to be void. Why might we need that? Suppose you're writing a method that must return a number. So you specify the type in the method after its name, and you're sure that TypeScript makes you return a number. Again, it's for your own safety. Perfect. We're almost finished with today's video. But before we finish, I'd like to show you another way we can define an object's properties using TypeScript. Instead of using a type, we could define an interface. At a glance, it looks almost identical, except instead of the type keyword we use interface, and there is no equals sign. Most of the time, they serve the same purpose, but there are small differences. Interfaces are made purely for objects. They work nicely with classes, and they're extendable. For example, I can create a superuser interface by using the extends keyword and specifying which interface I'm extending. The superuser interface now has all the regular user properties, plus an isSuper boolean. On the other hand, we may use type aliases to describe primitives. For example, we could create a type called userAddress and assign it to the string type. Not impressive? TS has a feature called a union. We may say our type can be one of the following: X, Y, Z, but for now, I'm only hinting that such a feature exists. We'll pause here. Time to rest. We've learned the solid basics of TypeScript. In the next video, I'll deep dive into unions and type narrowing, so stay tuned. Thank you for watching, and see you next time.